Hello and welcome to this session. Here we are going to solve the question number 4 of the exam on May 2019 of Engineering Economics of the PENG certification in Canada. In this question, let's see the question. A medium-sized farm in Alberta is considering a new automated irrigation system that relies on advanced sensors and computers-based decision as a replacement for the current human-based irrigation practices that relies on an experienced grower. The farm has a minimum attractive rate of return, minimum acceptable rate of return of 7%. The table below summarizes the cost for keeping the experienced grower and the cost to acquire and run the automated irrigation system. So we have a table talking about a summary of the table, which is talking about two different systems. Use the information in the table to answer the following question. Let's solve the question. So according to this table, we have two systems, human-based system, automated system. Let's talk about the expenses of these two. For example, human-based, it doesn't have any purchase price, it doesn't have any installation of first-time programming, but automated system, it does. Automated system doesn't have any salary or benefit year, but human-based has. And the cost of the system reprogramming is something which we just have for automated system. And how much is the duration? 5 years. If the automated irrigation system is to be reprogrammed every year, is it economic decision to replace the experienced grower with the automated system? So is it beneficial if we want to replace the system, if we have to reprogram it every year? So this is the summary of this table. Let's solve the question. As you can see, we have to calculate the present worth for both of them and compare it together. The present worth for the old system, this is the old system, the human-based. What are the expenses? Every year we have annual expenses, 40,000, 3,000 for salary and benefit. So we merge them together. We have to calculate the present worth. For calculating the present worth for something which is payment, which is all the time paid annually, we'll use the P over A, present over annual. What is the interest rate according to the question? 7%. How many of the year? 5 years according to the question. So this value from the compound table is 4.12, and this is 43,000 times to 4.12. So the present worth of the human-based system is $176,300. Now we calculate this value for automated system. For automated system, we have these two expenses, which are the first time in the beginning. So these are the present value. So we merge them together. We don't need any compounding factor because it's for the present time. This is a reprogramming cost, which is going to be done according to the question every year. So this is something annually. For how many years? For 5 years. And what is the interest rate? Interest rate is 7%. Present over something which is going to be paid annually. For 5 years, 7% on 5 years, the value would be something. So when we merge them together, the value finally would be $199,200. So if you compare them together, it's better not to replace it because the cost of the new system is more than the cost of the current system. The present worth of the new system more than the present worth of the old system. In part B, if the automated system is to be reprogrammed every 2 years, is it economics decision to replace the experienced grower with the automated system? If it's gonna be reprogrammed every 2 years, what would the result? So as it's gonna be reprogrammed every 2 years, we have to calculate. That our calculation would be different. Let's go together. So the present worth of the old system, it doesn't have any reprogramming. So the present worth of the old system is the same as before, 176,300. But for the new system, first of all, we have to find the interest rate of the effective. The interest rate of the effective interest rate would be 1 plus I to the power of 2 minus 1. And why these 2 is coming from? According to the question, it's going to be programmed every 2 years, every 2 years. So I of effective is 1 plus I to the power of 2. 2 is coming from every 2 years, minus 1. What is the I effective? 1 plus 0.07%, 0.07% to the power of 2 minus 1, which is 14%. And I'm telling you that where this 2 is coming from, it's mentioned that the period is 5 years. Every 2 years, you have to reprogram it. 5 divided by 2 is 2.5. So we don't have 2.5. So we will consider it as a 2 years. So I mean that in 5 years, we have to pay 2 times. So as this payment is something which is going to be happening annually, we have to calculate the present over annual, I effective, and 2. I effective and 2. Present over, because maybe sometimes we don't have the value on the table. So we have the formula as well. The formula for P over A, the formula for P over A is as below. 1 plus I to the power of n minus 1, I times 1 plus I to the power of n. If we put 2 instead of n, and we put 14% instead of I, the value would be 1.6. So the present worth of the new system would be 150 installation and the first cost plus 12,000 times 1.6, which is 169,200. So the present worth of the new system is less than the present worth of the old system if you are reprogramming every 2 years. So we have to accept the project if we have to replace if the condition is like that. In the other part, it's asking you if the service life of the automated system is 10 years with zero salvage value, for a planning horizon of 10 years, do you expect a different decision for part B? So it's mentioned that if the service life of the automated system is 10 years, instead of 5 years, 10 years, what would be the result? So this part is the same as part B, but we have to just, instead of 5, you have to put 10 years and we will find the result. And thank you for watching this video. Wish you the best. See you on next video.